Yes, we are going to graph. You're going to give it your effort, right?
Yes.
Yes. Okay, so the goal is graphing today. And as we are graphing these, we're going to, right up here, we're going to be graphing some linear pieces. Down here, we're going to graph nonlinear. So there are other shapes, whatnot. And I have a note to myself to kind of remind me if I forget to talk about what it means to be discrete versus continuous, which is really easy, and it comes up in the Math Excel homework. Okay? So, y equals 2x minus 4. That's our first one we're graphing. Notice, what is my hint over here?
Pick at least 3x values.
Okay. Pick at least 3x values, which means I'm trying to suggest that you should set up an XY chart.
Oh, no.
Okay. If we don't know what a graph looks like, one of our go-tos is to do an XY chart. Now, I think it's in chapter 5 we start, I don't know how much you guys remember about slope-intercept form and those. We can graph using those. But for today, we're just talking XY pairs, okay? Nothing fancy. Now, if I say pick, and these are for linear ones, and keep in mind, these are linear because it's just an x. So it's just a x to the first, x to the first. So because it's just an x, it's linear. What are good, easy values to pick? 1, 2, 3. What's even easier? There's one value you missed that I like.
0, 1.
I love to use 0, guys, because 0 is always an easy one to use. Now, I'm happy with 0, 1, 2. If you wanted to put a negative number in there, you can, but for the moment, I'm not going to force that.
Well, I don't like that. If you put a 0, 1, and a 2, then a negative, another negative.
I put the negative up top. Okay, so with this in mind, what do I do with that 0 for x? How do I find the y?
You go to the y line.
No.
You go to a.
If x is 0, how do I find what y is when x is 0? What do you mean solve it? I'm going to take 0 and put it in place of
The 2.
x, and this might be what Ryland's meaning when he says solve it. So if I put 0 in here, I'm going to show some work over here. 2 times 0 minus 4. So I'm putting that 0 in place of x. 2 times 0 is
0.
0. 0 minus 4?
0.
Negative 4. So when x is 0, my y value is negative 4. Okay. Repeat the process. Put in 1. It's 2 times x minus 4, so this time I'm doing 2 times 1 minus 4.
2 times 1 is 2. 4 minus 2 is negative 2.
Okay, 2 times 1 is 2. You said it backwards and threw me off, but I think you had it. 2 minus 4. It's 2 minus 4. We're going to be at negative 2. And repeat the process one last time.
It's 2 times 4. 2 times 4 is 8.
No, 2 times. What number am I putting in?
2.
2.
It should be 4. And then 4 minus 4 is 0.
Are you guys with David here? Are we okay with that? Okay. Now, here's the other part of the question. Do you remember how to graph it?
Yeah. Well, no and yes. Well, 0, negative 4, you'd go to the middle. What? Yeah, no.
Okay. So xy pairs. So 0, negative 4. 0 tells me 0 to the left or right, so we're going to stay. Where's negative 4 tell me?
That way. Wait.
No. First number, x tells me 0 on the x-axis. Negative 4 tells me
I'll go down here.
Negative 4 on the y-axis, which means I'm going down 4. So remember, first number is left or right. Second number is up or down.
What? Oh, negative 2 is down.
Okay, hold on. First number, I have to do this in order. I won't teach it any other way because I want to get us all on the same page here. 1 tells me to go where?
Over.
To the right 1. Where's negative 2 tell me to go?
Down.
Down 2. And then 2, 0.
And then
2 tells me to go?
0. No, over 2.
Right 2. 0 tells me to stay.
I mean, so that's really.
Okay. Notice these 3 points formed a line, right?
Yeah.
They're linear, they formed a line.
No, I did. Like where, because I noticed that it fit that, or up 2 and then right 1.
You used your slope.
Yeah.
Even though I haven't officially taught slope yet, but that's good. I agree. You can use slope here. Now, with this in mind, guys, some of your graphs in homework, if I recall correctly, are going to ask, is this a continuous graph or a discrete graph?
That's
Okay. Okay. Why are you going to call this continuous?
Because it's up and down.
Yeah. Once I start drawing it, do I have to pick up my pen? Do I have to pick up my pencil? No. Once I start drawing, it's all connected, right?
Yeah.
So this is an example of a continuous graph. I wanted to throw that vocabulary out there so when you see it in homework, you're not, wait, what? It's a continuous graph because you never pick your writing utensil up. And I'll be honest, all these graphs we're doing today are continuous. When it's discrete means there's some kind of break in the graph. Maybe it's just dots, or maybe there's a jump in the graph. But if it's discrete, there's some kind of break in the graph. So just be familiar with that vocabulary, okay? Now, we got one more linear graph. Y equals 1/2 x minus 1. What am I going to say? I'm going to say pick some x, y values. I know Jacob just talked about, he figured out that there was a constant slope. You can use that too. What x values do you want to pick?
0, negative 1, I guess. 4. Oh no.
You're just picking random numbers.
Yeah.
Now, I will tell you, it is very rare that I will not say 0. Because 0 is an easy number to math with, to add, subtract, multiply, divide, right? So it's an easy number to work with. In this situation, because I'm multiplying by 1/2, do you want to have to work with fractions? Do you want to have to do half of 1?
No.
No. What numbers can we easily take half of?
2 plus 6.
Even numbers, right? I can do half of 2 pretty easy, half of 4, half of 6. So because my denominator is an even, it's a 2, what I will say is I'm going to call them multiples of 2. So 0, 2, 4. If you need to keep going, 6. You can use negative 2. But then the nice part is we don't have to work with fractions. Okay? So let's try this.
I mean, I think.
And it's doable with fractions, isn't it? I'm not saying it's not. I just know how you guys, well, how lots of students feel about fractions. You don't care for fractions, so I'm giving you a way out. So if we try this first one, 1/2, replace your x, so 1/2 times 0 minus 1. Okay, because half of 0 is 0, and 0 minus 1 is, no, minus 1. Okay, put in 2. So this time it's, instead of 1/2 x, it's 1/2 times 2 minus 1. Half of 2, what's half of 2? Just half of 2. Here's 2, what's half of it?
2.5. 1.
No, 1. So half of 2 is 1. 1 minus 1 is 0. And if we put in 4, what's half of 4? 2. Or in other words, maybe I should say, what's 4 divided by 2? That's 2. 2 minus 1 is 1. Okay. You know how to graph these?
Yes. So down is 0, down 1. Okay, I'm gonna try to do this.
0, negative 1.
So you just go down 1.
First 0. The first 0 tells me left or right 0, so stay. And then negative 1 tells me down 1.
And then 2, 0, you just put, you go over 2, and it stays.
Positive 2 tells me to go right 2. Up or down 0 tells me to stay.
And then 4, 1, you go up 4, number 1.
Now, first number, 4, tells me to go
Over,
left or right. So we're going to go over 4. The second number tells me to go up or down. So 4, 1. Okay, so I went right 4, up 1. Did my points make a straight line again? Yeah, they did. Is this graph continuous or discrete? It's continuous. It's a line. I'm going to graph that line. It's going to be continuous. I'm not going to have to pick up my writing utensil. So there you go. Okay. These were linear. You guys are most familiar with linear because it's that y equals mx plus b form. Y to the first, x to the first, linear. What do you notice about the next two? What do these next two have in them?
What? I just was staring off from space.
What's different about these next two equations?
There's lines.
There's lines. Okay, what are those lines?
What are those
Lines.
They mean something. They have a name.
lines? They're just lines. I don't even.
What do those straight lines mean? We don't remember?
I don't think.
No one?
No. Symmetry? I don't know.
How about absolute value?
Oh, wow.
Did we forget that?
Yeah. Well, it's been a minute since we used those.
Okay, absolute value. Those straight lines mean absolute value. We're going to have to work on that, guys. Now, we're going to graph these the same way, though. It's just they're not going to be straight lines anymore. Okay, absolute value makes a different shape. Notice what I said here.
Only straight line value.
Instead of just 3 values this time,
Usually 5.
I want 5. And the reason I want 5 is because they're not just a straight line. So we need more than just 3 to be able to see what's going on. Now, if I say pick 5, what numbers are good?
Yeah, 0.
I like the beginning, but when I want 5, I need us to also pick some negatives.
Okay, so 0, 1, negative 3.
Negative.
About 0, 1, 2, and negative 1 and negative 2.
I do not like negatives at all.
Well, whether we like them or not, we have to deal with them, right?
Yeah.
So, now, okay, here's going to be the struggle. You guys don't even remember they're called absolute value bars, so do you remember what they do?
No.
Huh?
I don't have so
How do we solve it? Well, let's see.
I don't know. I know the other. Well, maybe.
Okay, so when we put in negative 2 here, right? Because we're putting it in for the x. So when we put this in, let's see what we can figure out here. Absolute value of negative 2.
Absolutely.
What do those bars do to that number?
Oh, you change them out?
We can't take them out until we do something.
You multiply.
Okay, so absolute value, by definition, is the distance something is from 0. Now, a distance. When you travel a distance, can a distance be negative? Did you drive negative 2 miles to school? No. Even if you drove in reverse, you didn't drive negative 2 miles to school. Okay, that's distance is always positive. So absolute value bars always make whatever's inside of it positive. So what's the absolute value of negative 2?
2.
Positive 2. And so then we're going to do positive 2 plus 3.
Well,
And
that's
2 plus 3 is
5.
5. So absolute value always make a number positive. So let's try the next one. This time it's absolute value of negative 1 plus 3. What's the absolute value of negative 1? 1.
So it's 4.
And then 1 plus 3 is 4.
It's 5, 4. Okay, this is going to be negative 0.
What's the absolute value of 0?
0.
0 just stays 0, doesn't it? Okay, it makes a number positive. Well, 0 is 0. And 0 plus 3
It's 3.
is 3. Okay?
And then, it's going to be negative 1, so it's going to be.
Oh, hold on.
Now wouldn't it just be the opposite?
No. What is it? What did I say absolute value always does? It always makes it positive. So if it's already positive, it's just going to stay positive. So the absolute value of 1 is 1. And 1 plus 3?
8. Just get 4.
Okay, last one. I'm running out of room here. I wrote too big at the beginning. Absolute value of 2 plus 3.
2.
So absolute value of 2 is
2.
2. 2 plus 3?
5.
Big math here of 5. Okay,
Alright, so negative 2.
we got to graph these dots. Negative 2, 5.
You're going to go down to
Oh, what's the first number? Always tell me. First number is
negative.
left or right.
Well, it's going to be left.
We're going to go left 2.
And go down 5.
Second number tells me up or down. Where's a positive 5 take me? Up 5. Negative 1, 4. Negative 1 takes me
That way.
left or right, so left 1.
And
Positive 4 takes me up 4. 0, 3. 0 takes me
Well, 0 takes you to the middle.
nowhere, right? Left or right, 0. And then 3 takes me up 3. Now, don't stop graphing here. Put some more dots. What about 1, 4?
You go over 1 and you go up 4.
Okay. Right 1, up 4. And 2, 5.
And then you go over 4 and go 5.
Right
This is
2,
like a V.
up 5. That's exactly what it is. Absolute value graphs are V's. Okay? Absolute value graphs are V's.
Okay, not gonna lie, that was not bad.
Okay? Can you still draw it all at once without lifting your pencil?
Oh, what?
So in the discussion of is this still continuous or is it discrete? Can I still draw it all at once?
No, yes.
Yeah, I don't have to lift my pencil and turn that corner on that V. So this is still continuous. Okay? It is still continuous. There's no spot where I have to lift my pencil to finish the drawing. Okay. And I will say absolute value, you want to write it there somewhere, it is a V. Your graph is a V. So,
Absolute value is
as we look at the next example here,
okay.
what x value do I want you to pick? I want 5, I want negatives and positives. And hopefully you see now, it's important that we pick negatives and positives, because otherwise we would have gotten a straight line over here and not the V. Now, stay with me on this. When I put this in, the first value, absolute value of -3 times -2, and then -2. It's kind of like parentheses. Before you can work outside, you have to work inside. So what is -3 times -2?
6.
6. And so then we're doing the absolute value of 6.
6.
What is the absolute value of 6?
Negatives.
No. Absolute value of 6 just stays
The same.
positive. So it's 6.
Minus 2.
And 6 minus 2, which is 4. Okay. Repeat the process. Absolute value of -3 times -1 minus 2. Work inside those bars. -3 times -1,
Positive 3.
positive 3. What's the absolute value of 3?
3.
3. And 3 minus 2 is
2.
1. Put in 0. Start inside the bars again. -3 times 0.
0.
Anything times 0 is 0. What's the absolute value of 0?
0.
0. 0 minus 2?
0.
No. 0 take away 2? -2. Okay. Put in 1.
That's gonna be 1.
So absolute value, -3 times 1 minus 2. So -3 times 1?
3.
Well, officially, -3 times 1 is -3. What's the absolute value of -3, though?
3.
3. And 3 minus 2 is 1. Okay, last one. -3 times 2.
6.
-6. Absolute value of -6 is 6. And 6 minus 2
4.
is 4. Okay, did you graph it?
So negative.
-2, 4. -2 says
So negative.
left 2, up 4. -1, 1.
So you go negative.
Left 1,
0, negative 2, 0.
up 1. 0, -2. Left or right 0, and then down 2. 1, 1. Right 1, up 1. And 2, 4. Right 2, up 4.
Right.
We still have a V?
Yeah.
Yeah, what happened to the V?
Bigger.
Bigger as in taller, is that what you're meaning? Yeah. I would call it skinnier. It's all because of that 3 there. Okay. So these absolute value function graphs are V's. Now we've got one other type here in the examples. And what do you notice about these?
There's
What's different about the
they
equation?
have a exponent
They have an exponent, specifically an exponent of x to the
third.
third. So in this case, we're looking at what an x to the third graph looks like. It's still not linear. So I still want you to pick 5 values. What 5 values do I want?
Pick 2, 3.
I keep with the traditionals.
So
Negative 2,
negative
negative 1,
0, 1.
0, 1, 2. Okay, what's it mean to do something to the third, to raise it to the third? What's that mean? Okay, times it by itself 3 times. So negative 2 to the third means I'm going to do negative 2 times negative 2
It's 4.
times negative 2.
4 is 6.
Now,
Yeah, we say. Well, 2 times 2 is 4.
2 times 2 is 4,
4
times another 2 is
4 times 2 is 8.
8. Negative times negative times negative is a negative. When you multiply 3 negatives, you get a negative. Negative 1 to the third.
Negative 1.
Negative 1 times negative 1
Oh, it's just
times negative 1, which 1 times 1 times 1
just 1.
is 1. 3 negatives again is a
Negative.
negative. 0 times 0 times 0.
0.
0. 1 times 1 times 1. 1. 2 times 2 times 2.
16.
No.
8.
I say, what was 2 times 2 times 2 earlier? 8. Now, this graph is going to look a little different, so let's get our points drawn.
That's kind of weird.
Upside down.
Negative 2, 8. Left 2,
And down 8.
down 8. Which it's 1 off my graph, so that's fine. Negative 1, negative 1. Left 1,
Down 1.
down 1. 0, 0. 1, 1 is
Over 1 up 1.
over 1 up 1. 2, 8. Over 2. Up 8.
Wait. 2, 8.
Mm-hmm. Now, what shape is this? Huh?
Type and shape.
It's not a shape. It's a curve is what I would say. And it's a curve. Oops, I kind of missed my center dot there. But it's a curve that, as it's increasing, it's going to cut through the origin there. So it's going to cut through those 3 dots. And then it's going to keep increasing pretty steeply there.
So that's linear.
Is that a straight line?
No.
Nope, not linear. Is it continuous though?
Yeah.
Yeah, I can draw that all with 1 line, right?
Yeah.
It's continuous still. Okay, one last one. Where are we at on time?
It's 2:48.
We got it. Okay. X, Y values. X values, again, we're going to use
The same ones.
same ones we've used for the last 3 problems, right?
Yeah.
Negative 2, negative 1, 0, 1, 2. Now, negative 2 times negative 2 to the third. When you're doing this, remember Aunt Sally. PEMDAS? Order of operations first, so exponents first, and then we'll multiply by negative 2. So what is negative 2 to the third?
8.
It was negative 8 over here, yes?
Yeah.
And then negative 8 times negative 2?
16.
16. So negative 2 times negative 1 to the third. Well, what is negative 1 to the third?
1.
Negative 1?
Yeah.
And then negative 1 times negative 2?
Negative 2.
Negative times negative makes it a
Positive.
positive.
Wait, I have a question. This is off topic, but how are you gonna get 216? Negative 2 or 16?
Will you just let me finish the problem?
Yeah.
Okay, put in 0. 0 to the third is
0.
0 times 2 is still
0.
0. Put in 1. Well, what's 1 to the third? 1 times 1 times 1 is
3. Whoa.
1
I'm sorry.
times negative 2?
2 negative 2.
Negative 2. And then put in 2. So negative 2 times 2 to the third.
2 times 3 is 6.
No. Not 2 times 3.
Oh.
2 to the third. What was 2 to the third?
8.
8 times negative 2.
12.
How about 16? Negative 16.
That works.
Okay, now I know it's hard to graph 16 here. We're just going to kind of go up off the graph a little bit, but negative 216 takes me left 2 and up 16.
It's basically,
It's approximately there. Why not?
alright,
Negative 1, 2. Left 1, up 2. 0, 0. 1, negative 2. Right 1 and down 2. And 2, negative 16. Right 2 and down 16. Yeah, it's down there. I can't even. Okay. Do you see a similar shape from last time?
yes.
Yes, it's just reversed, isn't it?
Yeah.
That negative reversed it. Okay.
Yeah.
Now, your homework, of course, is in Math Excel. I don't know if I have room to write it down here. It's lesson 4.4. Oh goodness, I'm writing too close down here. It's not working.